Hello everyone, this is Nitesh Kumar and welcome to Nitesh Labs. Today I am up with another video of design and development of gesture control spy robot. This robot can be a very good option as a final year project for engineering students. This robot is controlled wirelessly with hand gesture. The controlling range of this robot is 100 meter. Please feel free to contact me for any of your query. You can reach me through my mail ID or by commenting at the comment section. My mail ID is niteshkumar027@gmail.com. This complete system consists of three parts. First, transmitter card, second, receiver card, and third, mechanical body. I will deal in details with the design and development of both the card, that is transmitter card and receiver card, in this video. Mechanical body design can be created with the help of local hardware store. The effective range of controlling this robot is 100 meter. This robot, when attached with a wireless camera, can be used as a surveillance or spy robot. Working video of the robot is put at the last. All the necessary files and code is provided for downloads. I also request you to please share this video with your friends. This is the complete schematic of gesture control wireless transmission card. Here the major components are LM324 quad op-amp. I'm talking about this. ST12V decoder, this one. LM7805 voltage regulator, it is placed over here. ADXL335 accelerometer, this is placed over here. I have just created the footprint so that you can insert the module and solder it on the board. 415 MHz RF transmitter, this is placed over here. Similarly, here also I have just created the footprint so that you can insert the module and solder it. 10K presets, like here, total of 4 presets are used, 1, 2, 3 and 4th. Now let us try to understand the working of the circuit. Here I have used a voltage regulator 7805. This voltage regulator converts the given input voltage to 5 volt, and this 5 volt is being used by all the devices which are working or placed over here, like quad op-amp, 415 MHz transmitter, ST12V decoder, LM324 quad op-amp and so on. So the input for this 7805 is being given through a 9 volt battery. You can also use a 12 volt battery, but it will be a bulky thing. So since it is a handheld device, so it is preferred to use smaller 9 volt battery. Now let us try to understand the signal flow. Here the accelerometer generates the signal which is fed to the LM324 quad op-amp. Accelerometer signals are fed to the LM324 quad op-amp. This is the accelerometer signals, and this generates the signals which is fed to this quad op-amp. Here LM324 is used as a comparator. So this is an op-amp, this is a quad op-amp. It can be used in the various ways. So what we are doing it here we are using this particular thing as a quad op-amp. Quad comparators. So we are generating 4 comparator circuits out of this. Here 4 comparator voltages are created via 4 10K preset resistors. So what we are doing, we are generating actually four comparable voltage via this four 10k resistors. So you can see, so these are the four, sorry, these are the four 10k resistors, 1 2 3 and 4. All are getting the inputs from this LM7805 voltage regulator. V0 is feeding this as a input, and then they are these are getting into this LM324 quad op amp. So they, all these four creates four different reference voltages which are being set with the help of this presets. Now the four comparator voltages are then compared with the signals coming from this accelerometer. So this accelerometer generates basically six signals: plus x, minus x, plus y, minus y, plus z, minus z. So when you tilt this accelerometer towards right side, left side, upside, downside, or if you take it to bottom level, close to the earth or away from the earth, so all this corresponding six signals will be generated. Here we are not using the z axis, we are only using x and y axis. That is why we are taking considering only four signals. Now these signals, when this device is tilted, it generates the signals, and when this generate the signals, they enter into this LM324 quad op amp. Here already we have created some we have already created the comparator voltage signals. So which is here we the signals generated from this accelerometer are compared with those standard voltages which we have created as the reference, and when found equal, then this op amp generates this output signal. So when the output signal is being generated by this LM324 quad op amp, it is then fed to this ST12V decoder. ST12V decoder then decodes these signals and then transmit this signal via this RF transmitter. This is the complete working of this schematic design. Once you are done with the schematic, now it's time to go for the layout. You can use any of the PCB design software you want. Here I am using Design Spark for my convenience. This is the complete layout design of the board. I'll just enlarge it for your convenience. This is a double-sided board. Length of the board is 80 mm and the width of the board is 67 mm. Now let us look at the placement of the components. Yes, sorry. This is the complete placement of the component. As you can see, this U2 is quad op amp, this R1, R2, R3, R4, these are the four 10k preset resistors which are placed along the quad op amp IC. Next to the R3 I have placed U1. U1 is nothing but ST12V encoder. R1, R19, these are the associated resistors which helps in tuning the ST12V. Just top of the U1 is the IC1. This is LM7805 voltage regulator. Left to the IC1 LM7805, sorry, okay, so this part is reserved for the accelerometer. Toward the right, this space is being created for inserting the 415 megahertz transmitter. You can place it and solder it over here. This is the LED which is placed to indicate that battery voltage is coming. This bug is kept over here so that you can solder the wires, and then you can connect the connector so that you can connect the battery through this. So this is a complete layout design, layout diagram which will help you in placing your component on the board. Once you are done with the placement, you can start routing according to your convenience. So let me show you a complete routed board. This is the complete routed board. Now let me show you only the top layer. Yes, this is the top layer. Almost nearly all the components are placed on the top layer, as you can see. Now let me show you only the bottom layer. This is the complete bottom layer. Now let me show you the complete board once again. This is the complete board. Now let us convert the design into a 3D design and see how it looks. Going to the 3D view and thus generating it. This is the 3D view of the board. Here you can see this is the top layer. This is how it will look once everything is assembled on the graphics design. And this is the bottom part. This is complete schematic of gesture control receiver card. The major components of the cards are one Atmega 328P microcontroller IC from Atmel. This is the one. Sorry, this is the one. 433 megahertz RF receiver which is used here. ST12D decoder IC. This one. LM7805 voltage regulator. This is used here. This one. L293D motor driver IC. I'm talking about this IC. Arduino Nano board. This is put here. This complete configuration. Some resistors, some capacitors, some indicator LEDs, and some terminal blocks. For convenience, the schematic is divided into 4 different blocks. As you can see, this is the first block, which I have called it as a RF receiver section. This is the second block. This is the microcontroller section. This is the third block, which is a motor driver and power supply section. And finally this is the fourth block, which is the Arduino Nano section. Now let us try to understand this, how the signal flows in this board. Whenever the signal is transmitted via transmitter, the receiver, the RF receiver which is placed here, I'm talking about this one, receives the signal and then perhaps sends the signal to ST12D decoder. The ST12D decoder decodes the signal, and then that particular signal is being fed to the microcontroller. This microcontroller IC at Mega 328P. This microcontroller then processes the signal according to the code what we have put, and then provides signal to motor driver IC L293D IC to rotate the motor during particular time and particular direction. To make the work easy, I have also made a provision for Arduino Nano board. This Arduino Nano board is connected in parallel with this at Mega 328P microcontroller. So if you are having any problem in getting the particular at Mega 328P microcontroller IC, then perhaps you can use Arduino Nano board. Both can be programmed via Arduino platform, so you can use either of them. There is no need to put both. So this is once you are done with the schematic, it's now time to go for the layout. You can use any of the PCB design software you want. Here I am using Design Spark for my convenience. This is a complete layout design of the board. As you can see, this is the double-sided board. The length of the board is 95 mm and width of the board is 100 mm. Now let us see the placement of the component, which is one of the major thing, where the components are placed so that you can start routing. Yes, this is the one which gives you a clear indication where you can place the component. This section contains the ST12V decoder IC. This is the ST12V decoder IC which I have placed here, and these are the associated resistors and capacitors and LED indicators which are required to run this IC. This is the place kept for the RF receiver. This is the place, this is the SMA connector which is put here, where you can place the antenna for receiving the signals. Once the signal is received by this RF receiver, it is then fed to the ST12V decoder, and then the signal is then transmitted to the at Mega 328P microcontroller, which is placed here. This is placed here, which then processes the signal and then feed the signal to the L293D driver IC, which is placed here. Here I have put the LM7805 voltage regulator. This is the terminal block which takes 12 volt input, and then this 12 volt input is being fed to the LM7805 voltage regulator, which in turn generates 5 volt, and this 5 volt is being supplied to all the ICs which are here for their functions, or it provides the power to complete board. These are the terminal blocks through which you can directly connect the motors. This here I have
made the provision for Arduino Nano. This is the place where I have placed Arduino Nano boards. This is connected in parallel with this Atmega 328P IC. So you can, as I have told you earlier, you can use either of them. Either you can use Atmega 328P standalone IC and program it with Arduino platform, or if you are not getting that, then you can use directly Arduino Nano board and place it over here and get your work done. This is about the top placement of the components. Once you have placed the component, you can route according you can route in a way you want. This is the complete routing which is done by me. Now let me show you only the top layer. So this is the top layer of the routing which I have done. Almost all the components are placed in the top layer, because it could have been placed in the bottom layer as well, but there was no need, I felt like that. This is the complete top layer. Now let me show you only the bottom layer routing. This is the bottom layer routing. Let me show you the complete board once again, and this is the complete board. Let us generate the 3D view of the board and see how it will look once it is fabricated. So just going to the 3D view, generating a 3D, and this is how it will look once it is fabricated. This is the top layer and this is the bottom layer, you can see.
Now coming to the mechanical design of the robot. The mechanical design consists of two parts. First, robotic platform, and second, wireless camera. The robotic platform can be created as shown in the image. The robotic platform can also be created using acrylic sheet or any other metallic chassis available in the market. You need to fix 200 rpm DC geared motor at the rear end with 4-wheel arrangement. The base plate need to be kept longer for fixing the wireless camera. You can mount the camera on the base plate or on the top plate. It is up to you. Camera and 16x2 LCD mounting positions. You can mount the camera in either of the way as shown in the two images. You can put either RF camera or IP camera, it depends upon you. The camera costs around $1,500 to $2,500. You have to mount an 16x2 LCD as shown in the image. This LCD demonstrates the command and vehicle status on real time. Now let us see the working demo of the robot. Control signal for the robots are transmitted by tilting the card up, down, right and left via gesture. Wireless SD camera is used to view live image directly on the mobile phone screen. Camera movement is also controlled wirelessly. This is the 3D view of the robot. Transmitter section is also placed next to it. Now here we are able to see the live image of the camera on the mobile phone screen, and we are also able to control the camera direction through the mobile phone application. See, we are moving the camera towards up. Now the camera is tilted downward direction. This is towards the right and left. So we can tilt the camera in any of the in X and Y direction, and all things are controlled wirelessly. The LCD attached to this robot displays the command which are given to the robot. The robot is moving forward, as you can see, and in the LCD displayed moving forward, moving backward. Now I'm rotating the robot to in the right direction. Now this is the rotation of the robot in the left direction. See, if I tilt the card downward or upward or sideward, the robot will react accordingly, and the image is also transmitted live on the mobile screen. The box is just used for keeping the card and the mobile phone on the top. There is nothing inside the box. Thank you for watching this video. This was a video on design and development of gesture control spy robot. All the necessary files, codes and Gerber files are provided for download at the description. If you want to build the project, all the necessary files are available for you to download. I also request you to please share this video so that it reaches the people who are actually looking for such kind of videos, like robotic enthusiasts, hobby electronics people, robotic group people, etc. Thank you once again.